In question 1, we are asked to prove this trigonometric identity. Let's start to analyze it. The left-hand side contains a sum of two expressions. The right-hand side is a single expression that looks simpler. So it makes sense to start with the left-hand side and transform it to get the right-hand side. However, if I look at the right-hand side, I never work with the second and cosecant functions, and I know that secant of theta is 1 over cos theta. So I have in my mind that I need to end up with this expression of cos theta. From other point of view, in the left-hand side, I have tan, cos, and sine. So it makes sense to write tan theta as sine theta over cos theta. And then what I see in the left-hand side is a sum of two fractions. So I'm going to add the two fractions because in the right-hand side I have a single fraction. So I will start with the left-hand side, which I can write as sine theta over cos theta plus cos theta over 1 plus sine theta. I need a common denominator, so it's going to be sine theta brackets 1 plus sine theta plus cos square theta over cos theta brackets 1 plus sine theta. I never open the brackets on the denominator because see, my bed is open. Because if you look at the right hand side, you need to end up with 1 over cos theta. So I have the cos theta on the denominator, so I need to cancel the 1 plus sine theta. So I hope that on the numerator I'm going to end up with a bracket which is 1 plus sine theta. So I'm going to open the brackets on the numerator only, and I get sine theta plus sine square theta plus cos square theta over cos theta brackets 1 plus sine theta. And now the next thing to notice is that sine square theta plus cos square theta gives me 1, so I'm going to replace it by 1. Sine theta plus 1 over cos theta brackets 1 plus sine theta and now see how this whole brackets cancels. So I end up with 1 over cos theta, which is secant theta, which is the right hand side. In a proof that question is very important to show all the steps as the answer is given. So you need to show that you know how to reach the answer, which in our case is the right hand side. In question A, I'm asked to sketch the graph of y equals 3 cos 2x plus 1. The important features of a graph, of a trigonometric graph, are amplitude, which is in my case 3, period, which for cos x the period is 360 degrees. 2x represents a horizontal stretch by a factor of 1/2, so the period is going to be 180 degrees. And then y equals cos 3 cos 2x will be between -3 and 3. So if I have y equals 3 cos 2x minus 1, take away 1, needs to be between -4 and 2. So my graph is going to be between -4 and 2. Starting from when x equals 0, cos of 0 is 1. So I start from 2 with an amplitude of 180 degrees. So I need to end up here. Minimum point will be halfway between. So somewhere here. So my graph will look like this. What's going on with my pen? Question number 2. State the amplitude of 1 minus 4 sine 2x. Amplitude is 4. State the period of tan 3x. Y equals tan x has a period of 180 degrees. So y equals tan 3x represents an horizontal stretch by a factor of 1 over 3. So it's stretched, it's smaller by 3 times. So the period shrinks as well 3 times. So the period is 60 degrees. Question 3. We need to solve this trigonometric equation. 3 sin x cos x equals to cos x. The most common mistake is when students divide both sides by cos x. So I'm going to solve it in both ways, using this common mistake and in the correct way to see the difference. So, divide both sides by cos x, and we get 3 sin x equals to sin x equals 2 over 3. Using the calculator, x is 41.8 degrees. Now, because the domain is given in degrees, I need to give my answers in degrees as well. Is there another angle which gives me the same sign between 0 and 180 degrees? So sine of x equals 2 over 3. There are two angles. One is in the first quadrant, the other one is in the second quadrant. This one is 41.8 degrees, this angle here. So the other one is going to be 180 degrees minus 41.8 degrees, which will give me 138.8 degrees. So two answers. X is any of the 41.8 degrees, 138.2 degrees. Now, this is not totally right because you lost a solution. The way you should do it is, I can't divide by cos x because it can be 0. But what I can do, equivalent to what I've been doing now, is move the right hand side into left, and I have 3 sin x cos x minus 2 cos x equals 0. Now I can factorize the cos x, and I get cos x 3 sin x minus 2 equals 0. And see how I have now two solutions. Either cos x, or two equations give me solution. Either cos x equals 0 or sin x is 2 over 3. Of course, from this equation, last one, I get the same solutions as in the first wrong method, but I have new solutions. Cos x equals 0 between 0 and 180 degrees is x equals 90 degrees. So my full set of solutions is 41.8 degrees, 90 degrees, 138.8 degrees, 0.2 degrees. And these are all solutions. So by dividing by 0 in your by cos x in your equation, you lose part of your solutions. You lose some solutions. You can't divide by an expression both sides of an equation unless you are sure it cannot be 0. If it can be 0, you just move both expressions in one side and then you factorize, which is equivalent of splitting this equation into two smaller sub-equations. This one is a different type of equation than the previous one. So in this case, my equation contains sine square y and cos y. You can't solve an equation if there are two different trigonometric functions. You need to reduce it to a single trigonometric function. What we have done on the previous slide was that we got two equations, one in cos x and the other one in sine x. So it was in each equation a single trigonometric function. Here you have two trigonometric functions, so you need to see a single one. This is why the formula, in this case a formula, sine square y plus cos square y equals 1 helps, because I can replace sine square y in terms of cos y, and then I will see a single trigonometric functions. I will see only cos y, even if it's to the power of 2. I will never try to replace cos y, because from this equation cos y will contain a square root, so it's going to give me a too difficult trigonometric equation. So I'm going to replace sine square y, and I get 10 minus 10 cos square y plus cos y equals 8, or equivalent 10 cos square y minus cos y minus 2 equals 0. Now I will use a quadratic formula by letting cos y be, for example, t. So my equation is 10t squared minus p minus 2 equals 0. So see, I end up with a quadratic equation. So the solution of my equation in y are cos y equals minus 2 over 5, and cos y is 1 over 2. Therefore, from cos y equals 1 over 2, I get y equals 60 degrees. Is it the only solution between 0 and 360 degrees? If cos is 1 over 2, the x-axis is a cos axis, so 60 degrees, and also I have this angle here, which is 360 minus 60 degrees, so two solutions between 0 and 360 degrees. From the second one, cos y equals negative 2 over 5, I always look for the angle in the first quadrant, which gives me the related cos. So I'm going to always look for 2 over 5 as a cos. So the angle giving me cos 2 over 5 is 66.4 degrees. The angles that I need are there with a negative cos, are in the second and in the third quadrant. So the angles that I need are going to be y is 180 minus 66.4 or 180 plus 66.4 degrees. So now my final answers will be: y is any of the following angles: 60 degrees, 113.6 degrees from 180 minus 66.4, then 246.4 degrees from this one, and the last one, 360 minus 60, 300 degrees. So I have 4 angles.